what are the certification process which is carried out in order to launch or in order to subject aircraft in space or to its motion. What are the analysis part which will be carried out in order to certify an aeroplane. So we have to consider many factors which will affect the aeroplane with respect to what are the analysis which can be carried out. What are the analysis which if we carry, we can have a safe as well as better design or as a better performance of an engine with respect to the analysis part of each and every component with respect to the material or with respect to the shape with respect to the capacity or with fatigue and the dynamic tolerances. We are just need to find out what are the characteristic performance which when the flight is exposed to the atmosphere. Just with respect to all these analysis only we can find out whether this flight is can be left for its this aircraft can be subjected to a flight or it is capable quite enough to be capable or not. Just with respect to some of the analysis part, now I am going to deal about some of the major analysis part which the nozzle or a wing can be subjected through analysis part and finding out which will be whether the nozzle or a wing will be suitable for the flight. Here the major consideration which we are going to discuss about the structural analysis, the dynamic analysis, the aeroelastic analysis, the fatigue analysis, acoustic as well as the safety analysis. If we get all this analysis only, then it is subjected to FAA, that is in the sense Federal Aviation Authority. After subjecting the information as well as after subjecting the process over this collecting information about this process and subjecting over FAA, they will be certifying whether this flight is quite able to travel over the space with respect to the atmospheric pressure or not. They will be discussing. Now we will be discussing about what are the analysis which will be carried out in a nozzle or as well as in a wing. Now first we are going to consider about the structural analysis of a nozzle. Structural analysis in the sense we are just going to apply the loads as well as the stresses over the structural area in order to get up to which extent it can withstand the load or which extent it can be finer product without any failure or without any damage, or with respect to their life cycle we are just find out what are the things which we have to consider before going for a design. That and all we will be discussing before the structural analysis. After the structural analysis is finished, after the design is finished, we are just implementing this component into the structural analysis, where the structural analysis is done with respect to the FEA, that is the finite element model analysis. So that since it is a complicated model as well as everything, the load as well as the stress analysis, when it is exposed to nozzle is exposed to exhaust gases, so that it has to be subjected to a safety analysis as well, so that all the things can be done using the FEA model with respect to the element size or the boundary condition which we are choosing, and with respect to the FEA model we can find out what is the structural analysis and what are the loads here, what are the loads which can be applied, or what are the loads it has to withstand to travel in air. And just here I have drawn a diagram with respect to loads applied over this area, so that whether it is quite able to withstand these loads over this area, whereas for a conversion nozzle as well as for divergent nozzle, this red line represents the load which is applied over the nozzle. After the structural analysis only, they will be just certifying whether this is capable to it is capable to satisfy the load conditions as well as the thermal analysis in the sense the fluid which is flowing and the thermal activities which is carried out inside the nozzle as well. After certifying this, the structural analysis they will be subjected to the dynamic analysis as well. Dynamic analysis in the sense the vibration which is carried out when the flight is exposed to the atmosphere, since it has to subjected to a higher speed, it has to be subjected to speed which it can sustain or which it can able to do what are the which it can capable of being a safer journey for a aircraft or a safer journey for the flight. Here frequency helps us in finding out the they will be subjecting the actual vibration which the nozzle will be getting when it is subjected to the atmospheric condition as well as atmospheric pressure as well. This calculations will be carried out in the frequency using the damping as well. Here the damping in the sense it will be damping analysis will be carried out with respect to if the engine is fitted with the structural part. The vibration of this engine should not cause any damage to the structure, which leads to a damage of the aircraft, since it is a higher cost as well as the higher higher work done to build a craft, so that we have to be quite enough to concentrate on the design as well as its production as well as the analysis which will be carried out, which will not lead to a damage. These and all we have to carry out in the dynamic analysis with respect to the vibration, damping and frequency. Then more shape in the sense when the nozzle is subjected to the atmospheric air, at what pressure and temperature it can withstand, and in the sense it should not change its shape, so that it will lead to a reverse thrust, which helps us in reducing the thrust value, as well as it also leads to a damage condition of the aircraft. Here this mode shape is to be maintained at a better atmospheric pressure as well. These analyses are carried out in dynamic analysis, and the next one which we are going to consider in the nozzle is the fatigue analysis. Fatigue analysis is the fracture and dynamic fatigue and damage tolerance analysis, where fatigue in the sense whenever a stress is applied over the body, we can find out what is the maximum condition it can withstand or it can sustain without any fracture. We are just finding out with the help of the fracture analysis, and the dynamic analysis helps us in find out whenever it is subjected to any damage, whether it is quite capable to travel within the dynamic limit, in the sense it is whether it can be come to its safer position until a repair or rework is done. Here this process is carried out in a dynamic tolerance value, and with considering of this fatigue and dynamic tolerances for the nozzle, we are just finding out what are the characteristics of the nozzle material, as well as what are the characteristics which has to be subjected, and what are the failure it will occur when it is subjected to the atmosphere, and what are all the damage tolerances it has to be maintained in order to have a better shape. All are calculated in a fatigue and dynamic analysis, and after fatigue and dynamic analysis it has to be certified by a certain authority, and it has to be subjected for safety purposes as well. Then next one is we are going to see about the acoustic. Acoustics helps us we have to control the sound which is coming out from the nozzle, which should not affect the atmosphere, which should not affect the atmosphere, or in the sense which should not affect the people inside the aircraft. That has to be considered in the acoustic of the nozzle. After considering, after calculating all these analyses, we are just these each and every authority will be sending the information with respect to the safety. At the final, we are just going to subject these projects over to the safety zone, whereas they will be testing whether it is safe enough to safe enough to flight or not. They will be certifying whether with respect to the oil tank or with respect to the resonance, or in the sense acoustic. They will be finding out what are the drawbacks it is being getting, and what are the changes which has to be carried out in order to get a better engine. All are considered in the this analysis part, and finally it has been subjected to the federal aviation authority, and they will be certifying the aircraft whether it is good or whether it is quite suitable for a flight or not. Then with respect to the nozzle, the same procedure is carried out in the wing as well. With respect to the wing, we are just going to deal with the aeroelastic analysis. Here the aeroelastic analysis deals with the inertial as well as the elastic with respect to the aerodynamics. Here the wing structural analysis is carried out the wing using the CAE analysis, in the sense finite element analysis. The load can be applied directly to the structure. So structure, and we can find out up to what extent it can withstand the pressure or temperature. Temperature is also subjected with respect to the thermal flow. In the sense, CFD testing is also done using the structural analysis of the wing and finding out what are the weight will be acting over the wing with respect to the engine. We are just calculating what are the needs which it has to be subjected when it is subjected to the atmosphere. Just we can calculate what are the structural deflections it will suffer when it is subjected to the atmosphere. This and all is calculated using surface structural analysis, and in the inertial analysis it carries the same procedure as in the dynamic analysis, whereas the elastic analysis here it deals with the structural analysis as well. Then aerodynamics deals with when our aircraft is subjected to the air, what is the actual condition which is the aircraft or a wing. Here we are just considering about the wing. We here the aerodynamic structure has been this is the dynamic representation of the wing, whereas the air flows with respect to the aerodynamic flow of the air. Here we are just subjecting the wing to for testing, in the sense we are just subjecting the wing to a testing with respect to the air which is subjected to the aircraft in the atmosphere. With respect to the atmospheric pressure and temperature, we are just finding out what is the aerodynamics which is carried out over the structure of the wing in order to get a better performance, or what are the changes it has to be done in order to get perfect wing which will not affect the structure of the aircraft with respect to the performance. Once we have finished structural as well as the aerodynamic analysis and the fatigue analysis for this wing, as well as for the wing also fatigue analysis we are going to do, and with respect to the failure and dynamic tolerances which is subjected to the atmosphere is carried out, and for every each and every load condition as well as for thermal activities, what are the drawbacks it will be getting, or everything is calculated under the analysis part, and it is also subjected to the aviation authority, and they will be certifying with respect to the safety as well, and finally they will be certifying whether the aircraft is suitable for flight or not. With respect to these analysis, we can do what are the certification, we can get an idea about what is the certification process which is carried out in order to get a perfect aircraft. With this I end this session. Thank you.